The concentration of an air pollutant is measured in micrograms per cubic meter. Samples of air were taken at 2 different sites and the concentration of this particular air pollutant was recorded. For Site A, the summary statistics are shown below. We can see the number of samples and S squared A. For Site B, there were 9 samples of air taken. We don't know anything else. A test of the hypothesis, where we can see the null hypothesis, is that the variances are equal at the 2 sites, against the hypothesis that the variances are not equal. So that's going to give us a 2-tail test. Is carried out at a 2% level of significance, and that's going to be therefore 1% at each end. State a necessary assumption required to carry out the test. Well, the necessary assumption here is that the concentration of air pollutant at each site follows a normal distribution. So I'll just write the word normal rather than writing all of that out, but you need to write the whole thing. Given that the assumption in part A holds, find the set of values of S squared B, or SB squared I'd say, that would lead to the null hypothesis being rejected. So we know it's a 2-tail test. So there's going to be a critical value at each end. And what we're looking at is the values of SB that would put us in each of those regions. Now, from the same section of the formula booklet that we used before, I can see this. For a random sample of nx observations from a normal distribution ux sigma x squared, and independently a random sample of ny observations from a normal distribution mu y sigma y squared, we can use this as our test statistic using the F distribution. So we're looking at a 2-tail test, as we discussed. So we're looking at 1% each end. We'll go to the tables in a moment. But before we do that, we know that we're going to have values across the top and values down the side. Now, note that these are nx minus 1s and ny minus 1s. So we're going to be looking at F12, 8, because there were 13 observations for A and 9 observations for B. But alternatively, we could look at F8, 12. So we're going to need to find both of those values. Now, note that in our null hypothesis, we're assuming that the sigmas are the same. And that means that those will cancel out from our formula here. So we're looking at Sx squared over Sy squared being F and 12.8 or 8.12. We'll look at how to deal with that in a moment. The important thing for now is that the sigmas cancel. So I've got the tables here now. If we do it with the x here and the y down here. So if we take x is 12, y is 8, and we're looking at this value. Notice that we've got the 1% tables here. And so where they intersect, we're looking at 5.67. So Sx is the known one, so that's 6.39, which we got from the table above, over Sb squared. We want that to be greater than 5.67. The other way of doing it is to go in the other direction. So if we just get a different color to highlight, and let's go to 8 and 12. And those intersect here at 4.50. But that's with the other one being the unknown. So that's SB squared over 6.39 this time. Needs to be more than 4.50. So, working with the first one here. So we've got 6.39 over SB squared is greater than 5.67. And we can rearrange that to be that SB squared is less than 6.39 over 5.67. And that ends up being that SB squared is less than 1.127. Going the other way, SB squared over 6.39 is greater than 4.50. Just multiply both sides by 6.39 and SB squared would be greater than 28.755. Find a 99% confidence interval for the variance of the concentration of the air pollutant at site A. So 99% confidence interval is going to mean 1% split between these two. So we've got 0.5% at either end, which is 0.005 at this end and 0.995 at the other end. So I think those actually end up being the other way around, but it comes out in the wash anyway. What we're going to make use of is this, which we've got from the formula sheet. And so what we're going to have is n minus 1 s squared over the chi-squared n minus 1 value, and we're going to put that equal to the sigma squared. So we're going to need two chi-squared values, one from either end. And remember, chi-squared n minus 1, we know there were 13 readings. So 0.995 and n equals 12 is this value here. And then the other value is going to be the 0.005, which is the 28.3 at the other end. So we're going to do 12 times 6.39 divided by 3.074, and that gives me 24.9447. And then we'll do 12 times 6.39 divided by 28.300, which is 2.7095. And so our sigma squared will be between those values. So sigma A squared is going to be between 2.7095 and 24.9447.